Hi, good morning, everyone. I'm going to get us started so I don't eat in too much of our presentation time with introductions. I am so excited to see everyone today. Welcome to the first session block of the first PyData Virginia. We have an extremely exciting lineup of presentations for you in this block. A little bit later, we're going to get to hear about DuckDB. We're going to hear about NetworkX and cuGraph, and we're going to hear about multi-armed bandits. But first, we are really lucky to have Will Aid and Matt Topol here to talk to us about Apache Arrow. Will Aid is the author of the Pandas Cookbook, 3rd edition, and has served as a maintainer of the Pandas project since 2018. Will is also a committer to the Apache Arrow project. In his day job, Will helps clients in the retail and apparel space optimize cloud data platforms in AWS and GCP, while also providing strategy and training around the use of open source technology in enterprise settings. Matt Topol has been developing financial software since 2009. Matt has worked in infrastructure and application development, has led development teams, and architected large-scale distributed systems for processing analytics. Matt is a PMC member of the Apache Arrow project, with a primary focus on supporting and growing the Golang community. So if we have any Golang users, probably should come and find him after. Matt also wrote the first and only book on Apache Arrow called In-Memory Analytics with Apache Arrow, and has joined Voltron Data so he can work full-time on the Apache Arrow libraries. So with that, please join me in welcoming Will and Matt to the stage.
All right. Hey, everybody. Welcome to today's talk entitled Practical Applications of Apache Arrow. So just some background on this. Apache Arrow has been around for 7-8 years.
2016.
9 years. And it's probably a tool that you've heard about, but it's really hard to understand like what actually is Arrow. I hear about it, but as an end user, you don't necessarily use it every single day. So we wanted to give a talk that dives a little bit deeper into what Arrow is and show you examples where you may not be realizing that you're using it today, so that you come out of this with a better understanding of Arrow, its ecosystem, how it's going to evolve, and how if you do go a level deeper in your data analytics, how you can actually use Apache Arrow yourself. So there's just a brief agenda right there. We'll kind of divide it by sections. Just to frame who this talk is for, really wanted to split it up to 2 different target audiences. So we have what I would consider like data strategists. So this is, you may not be necessarily developing tools or libraries yourself, but you're probably familiar with them. You're thinking about how do I build an architecture in an enterprise or an organization to use data. For you, this talk is going to help clarify, again, what Arrow is at a high level and help you recognize what components in the ecosystem are all going to move together. In our opinion, Apache Arrow is kind of like the foundation of the future for data and analytics. So if you have a tool that's not using it, I would advise you to maybe rethink that. And if you do see a tool that's using Apache Arrow but maybe not that widely adopted, chances are it's going to grow and unlock the whole ecosystem of Arrow. If you're a developer, we'll clarify some Apache Arrow terminology and tooling and get you a level deeper. Now, this is a short talk. We're not going to go to an insane level of detail, but just to help with terminology and kind of ground you a little bit more on the inner workings of Arrow. And Matt, having written the book on Apache Arrow, is the best person, I think, to talk about that. We'll skip the intros. We already got those there. And Matt, I'll toss it over to you.
Yeah. So like Will said, we'll start off with just more of a high-level overview of what Arrow is. And, you know, the key thing to keep in mind is that Arrow is very much a fundamental underlying piece of many, many tools already. At its heart, Arrow is a specification. It's a format. It defines a specific way of laying out the bytes in memory to represent column-oriented data. And above and around that, the spec then describes things like how do you pass that data between systems via an IPC communication format. It also describes specifications for service definitions for how you pass data across the network. And the key piece here is to remember that the way the data is laid out in memory is identical in memory as it is on the wire, which means that contrary to things like JSON, protobuf, and stuff like that, where every time you go across a boundary, you have to serialize and then deserialize, which incurs copies, which incurs CPU cycles. And that way, Arrow doesn't have that overhead because you just take the raw bytes that are in memory, throw them on the wire, pass them off, and you then pull it back in, and you avoid that serialize and deserialize step, which also allows things for shared memory usage and even GPU handling. And there's implementations of Arrow in a host of languages, many more than I'm going to name, but you've got implementations in C++, Go, Python, Java, Julia, R, MATLAB. They all have, and then many more. So that's kind of the key piece here, is that Arrow enables this interoperability at a very, very low cost. And it's already been adopted by things like Google BigQuery, Data Fusion, and so on. So let's dive a little bit more. So I mentioned that it has column-oriented. And if you're not familiar with the term columnar, column-oriented, etc., the key piece here is that data of a given column is contiguous in memory, as opposed to more traditional, say, a struct. So you have like an array of structs where each member of the struct is then contiguous in memory, but if you only wanted to read one column of your data, you still have to read all of the data because you can't just read one chunk of memory of one chunk of bytes to get the column. By having the data be column oriented, where each column is contiguous, if you only needed one or two or some subset of columns of data, you only need to read that chunk of bytes. You only need memory usage for that chunk of bytes for the columns you're using. The other key piece here is when you start looking at modern CPUs and vectorization, SIMD, which is single instruction, multiple data, and so on. Those low-level processor details for improving performance require the data to be in contiguous chunks of memory. If your data is row-oriented and you want to perform analytics, you then have to either not benefit from that, or you have to copy the values into a contiguous chunk of memory before you can leverage vectorization and those optimizations. If instead your data is column-oriented, which is the way Arrow is laid out, there's no overhead to that. It's already contiguous, so it's very, very friendly to those vectorization optimizations. Okay, so we have our basic overview of what Arrow is. So what can we do with it? Well, as I mentioned, Arrow's format in memory is the same no matter what programming language you're using. And it has its IPC, inter-process communication format, which is just the chunks of bytes as they already are. Which means you can do cross-language communication by passing pointers to buffers of data. Okay, Arrow, specifically, we're at PyData, so I'm going to talk a little bit about PyArrow here, in terms of that PyArrow has a PyCapsule form description definition and has a CData interface, so that if you want to take your data from any language, as long as you can expose a C interface, you can then get that data into PyArrow or in Python at no overhead. It just pass the pointers, and then you can use it. There's a little bit of struct, a small struct with a little bit of metadata, but that's it. You're not copying the data itself. The data stays where it is, which means you avoid those extra copies. A great example of this is PySpark. One of the biggest examples there, usages there, is that PySpark can pass data between the JVM and Python without forcing a copy. It just uses the pointers. Yeah, Pandas has a PyArrow backend. Polars is built on top of Arrow. The entire reason why you get so efficient handling of data frames and interoperability between these libraries is when they support Arrow and the C interface. And that's the other key aspect of Arrow, is that interoperability between libraries, languages, and systems. It's not just that it's super efficient for the compute in memory, it's also super efficient for communicating between those libraries and between the systems. And that's why you don't necessarily hear about Arrow that often, because as an end user of Python stuff and libraries, you're not necessarily interacting with Arrow directly. You're primarily interacting with tools and libraries that are using Arrow under the hood to be efficient in how they talk to each other. And so if you're not the one building those libraries or building those systems, you're not necessarily interacting with Arrow directly. The other thing that I wanted to bring attention to was ADBC, Arrow Database Connectivity. If you're familiar with ODBC, JDBC as your standard for how you communicate with databases and data sources, consider the modern data system stacks. Nearly all analytic database systems are column-oriented right now for all the reasons I highlighted earlier. They're all column-oriented for the vectorization, for improved I/O, for memory usage, everything I mentioned. But ODBC, the primary way we communicate with databases, is row-oriented. So you have nearly all data systems are column-oriented memory, and then they transpose it into rows. That's a copy there, if you're not, copying and cost of transposing, to pass it across the ODBC interfaces. And then half the time we'll transpose it back into columns for, charting and visualizations and further analytics and so on and so forth. That's a heavy cost. As opposed to ADBC, which is a similar concept. You have a single client API, you code against the one client API, and then it's arrow-based instead of row-based, so it's column-oriented the whole way through. And then you have no transposition cost. No, you get rid of that extra overhead. And right now you can just, pip install ADBC driver Snowflake, pip install ADBC driver BigQuery, ADBC driver, SQLite. It even supports systems that are not Arrow native. And if those systems ever eventually support Arrow output, then they just get a performance improvement. But if your application is built on ADBC, when they upgrade to use Arrow internally, you don't have to change your application code. It's the same benefit of the reason why ODBC became so popular. Application side code just has one interface it communicates with. And for reference, I'm not just, blowing smoke here. Use case wise, it's shown. DuckDB, which turns out the next talk after us is a DuckDB person. DuckDB itself exposes the ADBC interface because it's just a C interface. So you can load DuckDB as an ADBC driver in process. And so a while ago, DuckDB published a blog post where they compared the DuckDB ODBC driver versus the DuckDB ADBC. And the important thing to keep in mind here is that when you talk about that, since DuckDB is an in-process database, your findings are not confounded by network latency. There's no network overhead that is being part of whether or not this is a true benchmark or not. It's all in process, which means this performance difference that you're seeing here between ODBC and ADBC is almost entirely just the cost of the transposing and the copying of the data. Because that's the only difference between the interfaces when you're talking about an in-memory database. And then when you start looking at things with Spark and JDBC and so on, because JDBC has a specialized jar that will give you Arrow data at the cost of transpositions and other things it does, but it shares the pointers and exposes it and avoids copies. But even then, that super jar, it's still not as fast as natively going through ADBC. Too much. Okay, so that's my piece there. And now Will's going to chime in and tell everybody more about the actual ecosystem around Arrow, things that utilize Flight SQL that I briefly mentioned, ADBC. He's going to talk a little bit more about the tools and things that already exist that you all could then leverage to benefit from Arrow.
All right. Thanks, Matt. In this whole ecosystem section, I really want to highlight where Arrow is applied in the entire stack from start to finish. So since we're at PyData, a lot of people have probably used the data frame library, polars, pandas, right? They both use Arrow. Matt touched on this before, but when you're talking about polars, which has come up in the past few years, I think what made that really popular and what is a great advantage for the polars library is it's completely Arrow-based from the beginning. Okay, so like if you compare that to pandas, which has been around since 2008, pandas had to build all this stuff on its own, and you know it did an okay job. But Arrow's like really the professional iteration of, hey, here's the type of data format you should be using. Here's how your type should be laid out in memory, and that took a lot of workload off of polars so that they could focus on what should a data frame library do, not necessarily like how do I need to do this low-level memory management behind the scenes. So it was great for polars. Now polars does also contribute a lot to the Apache Arrow Rust implementation, so that team still does do a lot of the lower level stuff, but it again gave us a real clean delineation between Arrow has the memory management, polars is the data frame library, and kind of what we would consider to be the front end to data analysis. Pandas, obviously a much older tool, a little bit later to the game to Arrow adoption, but it does have the PyArrow backend, and you can actually take any Arrow data type and wrap it with this pd.arrow d type. So it's a little bit more work to do. It's not quite as native as pandas, or I'm sorry, as polars. But if you use pandas in your organization, you can take advantage of all the great stuff that PyArrow does. And that helps you scale your data analysis. It makes string processing much faster. It helps with interoperability with any other tool in the ecosystem. So I strongly advise using the Arrow data types. If you aren't sure how to do that, we're giving away books later. The Pandas Cookbook 3rd edition talks about this a lot, so small little plug for that. Both libraries, though, utilize what Matt was just talking about with ADBC. Okay, so if you're interacting with SQL databases and you see that there's an ADBC driver, just really simple advice, use the ADBC driver. Okay, ODBC, JDBC, they've got us this far. Thank you for your service, but they've been around for, I don't know, 20, 30 years. It's time for something new. ADBC if it's available. Not every database has them yet, but soon. And yeah, this whole Arrow CData interface. So if you've seen, this has been actually a huge trend in the past year or two within the Python ecosystem. So many tools can interoperate with one another now. Okay, so tools that used to just work with pandas now actually work with polars. They work with cuDF. They work with all these different libraries. That didn't just happen by chance. That happened because they're all speaking Arrow underneath, and they could pass data back and forth between a data frame library, a visualization library. Ultimately, it gives you a lot of flexibility as a developer to decide, do I like polars, do I like cuDF, do I like pandas? Great, they all work, and I don't need to sacrifice the rest of my ecosystem thanks to Apache Arrow doing all the heavy lifting behind the scenes. So it's really helped out data frame libraries. Also databases, okay, so I've just called out a couple here. I could list every single database really benefiting from this, but here's just some simple use cases that have come up recently. Oracle has this Python Oracle database Python package, so if you use Oracle, you can actually get Arrow native data coming out of Oracle. Again, significant time savings, good type management. I also gave an entire talk on ADBC back at PyData New York City 2023. So if you want to know in very much detail about ADBC, check that out on YouTube. But Oracle, by having this in their Python Oracle DB Python package, is now getting all those advantages. Same with Snowflake. So Snowflake built on top of Nano Arrow. We didn't go in detail about Nano Arrow, but Nano means small. It's still an Arrow tool. It's a super small Arrow tool that gives you access to the layout and helps you build Arrow arrays. And what that was really useful for them was to reduce their package size. So they went from 50 megabytes down to 5 megabytes. Now, as an end user, you're probably like, whatever, I don't care. Who cares about 50 megabytes? My computer's huge. And for most people, that's true on your personal computer. But when you're talking about small containers, maybe you're using like a AWS Lambda runtime, it's actually really important to have super small binaries because it allows you to distribute workloads, 50 megabytes and 5 megabytes, if you do that 100,000 times, you get a huge difference in storage. So having a really small library that helps them communicate Arrow data gave them all the benefits of
We'll have Q&A at the end.
yeah, the Arrow type system, while making it really easy to put into a Lambda container. I'll talk about a developer use case. So PanTab is actually a library that I built, so I'm very biased and know a lot about this. But I had a use case 6-7 years ago where I was working with a client that used Tableau, and I needed to get data into Tableau. They have their own proprietary format. I was using pandas a lot. I said, great, I should marry those two together, and I did. That's where PanTab started. Awful performance. It was so hard to maintain. Every time pandas came out with a new release, my library would break. And that happened because there were no standards for data frame low-level access. And this applies to a variety of other tools. Plotting libraries would break all the time. Pandas had a new release. Anything that really built on top of pandas would, quote unquote, hack into the internals. And that was the state of the ecosystem in the mid-2010s, late 2010s. We've come a long ways, and now that Arrow's around, I actually switched PanTab to using Nano Arrow, and what that did was help with string performance. My throughput was probably 30 times faster to help people write these databases. It allowed for out-of-core operations, so it doesn't matter how much memory you have, you can write a file if you use Arrow. And then suddenly I supported all these other data frame libraries. It wasn't just pandas anymore. It's still called PanTab, I didn't change the name, but you could also use polars, you could use DuckDB, which stay around for the next talk on DuckDB. You could use PyArrow. Again, this whole ecosystem of data frame libraries I can now take and interoperate with Tableau, all thanks to Apache Arrow. Bunch of others. We're not going to go through all these because it's a lot, but just wanted to toss some logos up there to spark interest. Hugging Face, Rapids, those are two big ones. DuckDB, again, is a big tool in the ecosystem. But yeah, these are all kind of their perspectives. An interesting one that maybe a lot of people don't know about because we're at a Python conference. That's a JS-based tool, but it's a really good way to visualize Apache Arrow data using JS libraries. Okay, that's kind of the current state. We've come a long ways in the past, even year and a half. I'd say it's really rapidly evolved. How many libraries have built on top of Apache Arrow? So where do we go from here? Okay, well, when we look at like tools, there's a couple problems with open source tooling. One is like people get very biased on what their tools are. Everyone thinks they have the best tool and they can do it better, and that's great. You know, it's good to have that confidence, I guess. But there's a lot of time and effort wasted when you're constantly re-implementing the wheel and when you're arguing over, well, I like polars, I like pandas, I like R. Okay, great. Like you can have your own personal biases, you can pick your own tools. But at the end of the day, it's all data analysis, right? So why do we really fight over tools when they all kind of work and can do the same job? So Apache Arrow is that unifying language. Again, whether you use any of those tools, they can all work on the same data set without copying data, which is fantastic. And as more and more tools build on top of that, you're going to get better interoperability. We've already seen that. The trend will continue, better performance. And last point there, significant reduction in non-value added engineering, which is extremely important. I am not going to read this slide, but it's kind of interesting. Like Wes McKinney, who started the Pandas project and was one of the co-founders of Apache Arrow as well, he's given a lot of talks, and there's a link here that you can look to his composable data management system manifesto. So he's talked a lot, if you've seen his recent conference talks, about how do we make the composable system of the future. And we've seen that here in some small doses, like we have a data frame library, you know, you could swap in and out, maybe a couple database drivers. But when you think about your entire ecosystem, there's even more than that. There's file storage, you have database computations, you have query front ends, SQL query front ends, Python front ends, right? So regardless of like what you feel as a developer, how can we make this all work? Apache Arrow. If they all speak Apache Arrow, you can kind of pick what's great for you and your organization, but not have to pay the cost of copying data, really expensive computations, and any kind of, again, non-value added engineering. So Apache Arrow is all about the composable system. Build it yourself, pick what you want, and as more and more tools adopt Apache Arrow, if they do adopt Apache Arrow, they can be a part of that system. And yeah, here's just a quick slide on interoperability. I think Matt touched on this in some too. Again, we're talking about like, do not copy data from one tool to another. 10 years ago, someone on your team liked R, someone like pandas, great, there'd be this huge data copy between them, or they just wouldn't talk to one another. Those days are long gone, thankfully. A couple slides to learn more. I believe these slides will be distributed, so check these out after the conference. But yeah, there's a lot of resources there. Some from Matt, some from myself as well, and Wes. A lot of great information out there. And that is the end of the talk. So thank you very much for your time. And
That gives us a little under 10 minutes for Q&A.
yeah, I think we have 10 minutes for questions if anyone has any.
So there we go.
So let me try to, I guess, project the ecosystem that you showed with the data frames and then the database libraries. I guess if you're more used to using just data frames and that comes with database interoperability with pandas and stuff like that, is there any benefit to using something like a Snowflake connector, or is it because it's Apache Arrow all kind of the same functionality?
Okay, so I'll answer that one. And let me paraphrase for the mic as well. The question was, if you come from a background and you've just kind of used data frames, like, do you even really need any other stuff? Why maybe even use the Snowflake tool if it's there, right? The idea is you shouldn't have to. Okay, so let's frame, again, the history of that. Let's say like you're working with Snowflake as a database, but you're working with pandas as a tool, okay? Historically, to get those to work, you might not see it, but there's a lot of data copying behind the scenes. So Snowflake may have their own way of representing data. Pandas would have their own. If Snowflake is taking up 10 gigabytes of memory already, and then Pandas is taking up 10 as well, you may need 20 to copy between them, right? So there's time and effort that goes to getting the data across those different boundaries. Now, with Apache Arrow, if you use Snowflake's tool directly, or maybe use the ADBC driver for Snowflake, you don't need to change what you're doing. And you, as an analyst using a front-end tool like Pandas, you don't need to pay this huge memory cost anymore to get data out of Snowflake. In theory, they're using the same memory sitting out there somewhere in the cloud or in your computer. There's no copying being done, and you just work with it in its natural form.
Cool, so it's meant to be kind of like whatever your workflow is already, whether you're using the direct library or pandas, then it kind of just fits in and makes it a little bit more efficient.
Yeah.
That's the goal.
Yeah, I would say
that level of interoperability where, from the perspective of the developer, that you can just keep using your tool and it just works, but now it's more efficient.
Yeah.
That's the goal. That's the point.
That's great. Thank you so much.
yeah, if you have to change what you're doing, that's kind of counter to the idea of Apache Arrow. It's
That
like,
was my question.
Yep.
Basically, would I have to change what I was doing to get more functionality?
yeah,
Well, I mean, you'd have to, right now you'd have to be using pandas or polars as your front end stuff, and if you're using a different data frame library, and if they don't support Arrow under the hood, then you need to go put pressure on the developers of your data frame library, be like, hey, why don't you support Arrow? Can you please do that? And so on, because that's the point, is that interoperability, and we only reach that by the network effects of other tools also adopting it,
Right.
which that's another reason why we like doing talks like this for people that are not necessarily the ones under the hood building the tools, because the biggest way to get those other tools to support Arrow for interoperability is for developers like you all who use those tools to be like, I want to talk to that. I want my tool to talk to that tool without a whole bunch of copying. Make it happen and go put pressure on the developers of the tools that you use.
Or I can't use your tool at all.
Yeah.
Exactly.
yeah. Put pressure on your developers. Don't do it yourself, though.
Okay,
Thank
so,
you so much.
next questions?
I'd like to follow on with her question. And this is going to be more of like I'm a user of Arrow. And speaking of the network effect, like what is the ability or compatibility expectations for Arrow extension types to go across?
Do you want to answer that?
So I'm just going to paraphrase a bit. So the interoperability and ability of communications with Arrow extension types. If you're not familiar with Arrow extension type, so Arrow has its type system. And then there are what's called extension types, so that you could effectively tack on semantic information or semantic functions to an existing type in Arrow to provide more more contextual stuff. So, for example, there is GeoArrow, which adds a bunch of geospatial functionality, building on top of a couple of the, a straight like binary type or things like that. Now, with extension types, there are a few canonical extension types that are essentially accepted by the community as this is the way to do that thing. For example, GeoArrow, there's a JSON extension type, a UUID extension type, and the canonical extension types are the ones you should expect to be easily communicable among implementations. Extension types, one of the benefits of the way they're implemented is the fact that even if the underlying systems are not aware of the extension type, you can still pass the data through those systems, because an Arrow extension type is primarily just metadata on top of the existing physical type that it's implemented as. And it only matters whether a library understands the extension type at the point where you want to do stuff with the data itself. So, for example, if you are requesting, passing data and you have the JSON extension type, it matters that it's a JSON extension type if you as a developer want to perform functions on it at the top level, or it matters if you want your underlying data system to be able to recognize and do something special because it's a JSON type, not just a string. And so there's more work to be done there. Like, for example, it would be great if systems like DuckDB or Snowflake or others, for their geospatial data, outputted the GeoArrow extension type, and they currently don't yet. But even if your personal system does utilize the extension types, you can still do pass-through. You can still pass the data around with Arrow systems, and if they don't recognize that extension type, they will still treat it appropriately as the underlying Arrow type.
I think we have time for one more.
Do you think that pandas will go Arrow as a default for every single data type? And then why do you think it took so long for pandas to switch to Arrows for strings?
There you go. That's yours.
Whew. Okay, that's a loaded question. Just to paraphrase, the question is will pandas move to Arrow as a default, and why does it take so long to use Arrow storage as or for strings? I would love that. It's going to be challenging, and it's kind of the difficulty with pandas to me is like a big container ship, right? It's just been moving tons of data for years. Okay, it's hard to steer a ship. There's a ton of people that are glued into this is how I need pandas to work, and this is the way I want it to be. So, I would love for it to be Arrow native by default. We've had some discussions as a team, but I don't think it's going to happen in the next year or two. I still think it has such a history with NumPy that it's just really hard to kind of move away from that. And there's cultural barriers, there's technological barriers, there's bias barriers. There's just so many things that kind of work against that. So if you want to use Arrow data types with pandas, I think for the foreseeable future, you have to kind of more explicitly opt into it by using the Arrow D type. In terms of the string, kind of the same answer, the Arrow string data type kind of works the same as the strings pandas has had historically, but still not 100% the same. You can get down into the weeds on the differences, but it's okay, we have, 600 million downloads per month of pandas. How do we know which ones are really important that need this specific string functionality, and how do we kind of guide them down the path of getting more Arrow based? So in the Pandas 3.0 release, when that happens, if you have PyArrow installed, it should be using Arrow strings by default. But yeah, it's just hard to move a big container ship like that that's been around for so long. That's just why it takes longer.
If you have more questions, just come and find us. Also, we'll be doing a author chat and book signing thing during lunch.